Welcome back. Today we are doing lesson 2A in electronics for the Arduino starter kit. Lesson 2A is going to have a few things. Yeah, why is my email up? Well, I'll show you right away. So the first thing here to do, you're going to have to set up the coding app on your Chromebook and submit a picture that you got it working. You're going to have to read all of project 2, which is something we call the spaceship interface. Let's see if I can find that for you here. Sorry, folks. Right there. Right there. So you're going to read that, and you're going to do the questions for part 2, and I've got those right here where it says basic code theory. It kind of printed funny, so you might have a clean sheet starting right here. If not, you can use what we had before, and then you'll be doing up to that diagram. Once you get to these diagrams, that's where you would stop. We'll go over it a little bit more after. So the first step of today is to get the app running. Now, if you're doing this at home, if you're doing this on your own PC or your own Mac, you could actually download the application online, and the instructions are in this book. That's going to be a very rare exception, and if you're having problems, I can help you on your own. If we're ever in the lab has it pre-installed. It's a little program. It looks very similar to what you're going to be getting. But since we're on a Chromebook account, we pay a monthly fee, and you get access to this. So right now, you don't have the app on your school Chrome account, right? Your Chromebook account. So the first thing you need to do is get your computer and log in. So you have to type in your school division email address and your password and log in. Once you log in, where you need to go is to your email, because I will send you a code. So we'll get that all ironed out. I'll send you an invite, and you'll have a code right here. And it'll say, each student can use this code right here. Now what this is going to do is it's going to open up the Chrome app library, or the app store for Chrome, right? So you're going to click on that. Now for me, I've already got it on my account. So every time I load up any Chromebook, it doesn't matter. I've tried it on this Chromebook. I've tried it on this Chromebook. Anytime I load my login, it pulls the app up. It's already loaded on my computer, ready to go. So here it says Arduino Create for Education. Now what you would have to do would be get app or install, but I will have authorized you to get it. You don't even need a code or anything. I just send you the link. You will have to create an account, but that's very simple. You just make a username and a password and create it. And after that, you will launch the app, and look what comes up. Arduino Create. So you would go create a new account. You would create that account, and then you would make a username and a password, and you would log in. And it's a web-based way of writing code, and it's very slick. It works on any Chromebook. Any Chromebook you log into will have this. So it's just loading it up for you. There it is. So I've actually been working on 2 codes here for the spaceship interface, right? This one here, I've been working on. This is what you're going to be typing today. So you don't need to write the code yet. You would have a blank one. It would look like something like this probably. That's all that comes in. You can delete the void setup and void loop anytime you start over, but they always use it because somewhere in every code you're going to have a setup section and you're going to have a loop section. And we're going to learn about that today in this lesson, actually, what setup and loop means. I like to erase everything every time and start from scratch, and I'll type in void setup and void loop on every individual project. But that's what you're going to have. You're going to have something like this, and you're going to have to take a picture. So that is the first step. The first part of this lesson is to set up the coding app. So you're going to create a login and a password and submit a picture saying, boom, this is me, right? I've got my account, I've logged in, and I can get to coding. You can save codes, things like that. You can name different codes, and you'll have all your codes here and right there. is where you would type your code to run on your board. There's a little bit more to it. You have to decide where the code is going to go out to, but we'll do that later. So that's the first step, is get this running and submit a picture showing, hey, I got the coding app working on a Chromebook. And of course, if you're doing it at home, you can load the app yourself. That's on you. Read all of Project 2. Well, that's what we'll go right now. So read all of Project 2 and do the questions for Project 2 and submit. I think you should do that kind of with me right now. So I'll kind of show you the questions you need. Right? You'll be starting here, basic code theory. What does digital write mean? How would you use it? And then the next one, what does digital read mean? And give an example how you would use it to do something. So that's kind of what we're looking for. So I'm going to just kind of start with you here. And we're going to just talk in general terms about the project. So in this project, you will be building a spaceship interface. It's not really a spaceship interface. It looks like this, and you're going to put a piece of paper over it after, and whatever, we'll call it a spaceship interface. But that's the name of the project. Basically, you're going to be able to press a button and make lights flash back and forth. So the components you're going to need, a switch, an LED, a 220 ohm resistor. You're going to need 3 of those. You can't see that, sorry. And a 10 kilo ohm resistor, and you're going to have to look in your kit for a 10 kilo ohm and see if you got the right one. I believe this is what it will look like. So remember, your 220s are the blue ones with these wires on them. And that is the 10 kilo ohm one. It's got brown, black, gold, gold kind of on a brown resistor, not a blue one. So that's important, always getting your resistors right. So now let's just take here. So now you've got the basics of control. You're going to make a microcontroller. You need to read this section. It's just making something that would be looking like if you were watching Star Trek from the 60s. It would look like a blinking light in the background of the set. That's why they call it a spaceship interface. Very simple stuff. Now this is cool. The Arduino's pins. And what do they mean by pins? I don't see any pins. Well, all of these inputs here, inputs and outputs, right? Pins right here, like 13, 12, 10, 7, 6, 5. And then you've got these different analog in and outs. Those are all pins. And you can decide right here, it'll say, they have 2 states. When there is voltage on and when there is not. That is all they do. They sense, is there voltage? Is there not? If there's voltage, you would call it high. And if there is not, if there's no signal or no voltage, you would call it low. The next thing is these pins, they can be used to either read or write. What do you think that means? Well, if you set a pin to be a reading, digital read would be the code you would use, digital read, it means you have created that as a sensor. It is seeing, is there voltage coming to this input or not? It reads, digital read means that pin is always reading to see if there's signal. If there is not signal, your code will tell it to do one thing. If there is signal, your code will tell it to do something different. If it's high with signal or low without signal. So when you say digital read high or digital read low, you're saying read if this pin has signal high or if this pin has no signal. And the opposite or the other side of digital read is something we call digital write. And that's when you're sending signal. You're saying this pin or that pin will send high output, which would mean a signal, or it would send low output, which means it would send nothing. And depending on what your code tells the board to do, whether there is high signal or low signal coming out of that pin when it's writing, would determine what your board here does. So you've got digital read, means you're sensing whether things are coming in or not. And digital write means you're telling the pins to send signal or not. And high always means there's a signal. Low always means there's no signal. So that's kind of the beginning of what you're talking here. And you can look, there's better definitions in the book, but what does digital write mean? give an example of how you would use it. You can look in the book for that. What does digital write mean would be your next question, and give an example of how you would use that. And then we've got the next two questions that are kind of linked as well. What is a void setup and what is a void loop? And where would you put it and what does it control? So you've got something called a void setup and a void loop. And they're always coming here because every code you write will have a setup and a loop. So you can read this. So if you need to pause this, go through this, do the answers. Oh, sorry, I fell asleep. If you need to, pause this, go through it, do the answers, and then move on to the next questions where we start talking more about specific things. Now, don't wire up your board yet. You'll do that in the next project. So just read what you would be doing and see how you're going to be wiring. Keep reading there, and then we'll get here. Now, this is where we get to the void setup and the void loop. And there's definitions of each here. Now, what I will say is you need to read. So read the book and get a precise definition. I don't want to read an entire book for you on a video, right? But you're on those questions now. So it says setup and loop. Setup runs once, loop runs constantly. That's the biggest thing, but you need to explain that a little more. See, when you plug in your board and the code is uploaded, the setup is like the rules of the game. It runs one time. That's why it's at the top. So it's the first piece of code that runs on the board. You plug it in, you sync it, click the setup. It has programmed the board. It is telling the board what to do now. Now the loop is where you're going to write your code that is constantly repeating. It's running all the time, thousands of times a second. It's always saying, is this high or is this low? Is this high if this is low? Is this high? Is this low? Is this high? Is this low? It's always reading. It's either sending, depending on what buttons you're pushing and things like that. It's always sensing, is it getting signal or is it giving signal? Is it high or low? And it's reading constantly. It's running all the time. The reason you need your loop to run constantly is because if your loop just ran once and you didn't push the button when it ran, you could push this and it would never do anything. It has to be running, 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 running. I push it, oh, running with it on, running with it on, running with it off, running with it off, and it'll do different things. A loop is a set of code that has to run constantly. A setup just runs once and it sets the rules of the board. What's going to be an input, what's going to be an output, what's sensing for high, what's sensing for low, and if it gets a certain signal, what does it tell other parts of the board to do? Does that make sense? I hope so. A setup is the first code, so you could kind of go there, right? And you could kind of pause it now and look in the booklet. You're going to have a little bit more here on page 36, and you can read about setups and loops right there, and there's a little bit more about digital read and digital write. And this is the code you're going to be writing, and the stuff here on the next lesson, you should really be reading that on the next lesson more so. This will really help understand, like, as you're writing your code, like, what the heck am I actually writing? I don't know what this means. But when you read this, combined with that, and you have a little bit of background knowledge, you're going to be doing good. Next up, here we go. So, I'm going to let you go through the rest kind of on your own. Why does the code have to be written in a loop? I think I just said that. What are the two power states of inputs and outputs? Well, they're either low or high. What does that really mean? Signal or no signal, you can kind of work on that. This is easy. You could find that on your own. It has to do with comments. You can pause it. Pin mode, I'll give you a little bit of a clue here, but you can find the answers for when we're talking about pin mode. All right, let me see. There we go. Pin mode's right there, right there. It's on page 36. And what it's doing is it's basically giving a command for these different pins, right? You've got pin 6, pin 5, pin 4, pin 3, pin 2, pin 1, pin 13. You got analog pins over here. And you're basically, what pin mode is doing is setting ground rules for that pin. Use the definitions a little bit better here. I don't know if there's an appendix in the back of this one. Yeah, there is. So you could even use that too if you'd like for a more specific definition. What does if mean and else? And that means, like, if something happens, do this. And if it didn't happen or else do that. So it's like do this And if that didn't happen, do that. You'll have to read the booklet a little bit to understand what that means. But you got to know what these words mean. You got to know when you type void setup and make something, you're setting the ground rules. When you write void loop, you're setting a code that runs over and over. And the if and else give it options. If this is pressed, do that. Or else, if it's not pressed, constantly do this. And what is the difference between curly brackets and regular brackets in terms of coding? That is the last question, and you can obviously find that somewhere in here. Regular brackets are there, and I believe they tell you what the curly brackets do. Sorry, I don't want this to fall asleep again. So that's what you need to do. You can take your time. I'm going to give you a few days to work on this, so we'll have to get everything set up with your accounts. We'll get you logged in. You'll send me a picture of this. Then you can read all of the booklet of Project 2 and look at what you're going to be building. Don't start building it yet. Please wait till everybody's on the same task. Do all your questions and your answers. So you will take a picture of this. You will read along with me. Hopefully you've been reading. If not, go back and kind of listen to what I say because I kind of go through it step by step. And that's when you do the questions. You write the questions on a paper. If you don't have this paper, you can always just write, a number. Make a number for them and just write your answers on a paper and submit a picture into the assignment for this one for me. So that's what you'll do. And then for the next assignment, we're getting real. We're going to use this. We're going to write some code. We're going to wire this. We're going to understand what everything means in that code. And we're going to make this spaceship interface work. So that's coming up next. I'll give you a couple days to work on this. Lots of time. No rush. Do a good job. Use the appendix if you want, if that helps you. Take your time. Feel free to send me questions and ask me what you need. I hope you're getting it. The next lesson is going to be fun because we've got most of the technical stuff out of the way. There's going to be a lot less learning what certain terms mean and things like that. Because once we get into using it now, you will understand what this means after a few lessons. You'll know what the setup does. You'll know what the loop does. And you'll understand how your code is sensing all kinds of things. So take care. We'll see you soon.